Hello everyone, welcome to this tutorial. Today we are diving deep into one of the most powerful computer vision model out there, Mask2Former. If you are ever wondering how AI can understand and separate different objects in images with pixel perfect precision, you are in the right video. By the end of this video, you will know exactly how to use Mask2Former for three different types of image segmentation, and I will show you some mind-blowing results. So, what exactly is Mask2Former? Developed by Meta AI researcher in 2022, Mask2Former is what we call a universal image segmentation architecture. Now, what makes it special is that it can handle all major segmentation tasks with a single unified framework. Think of it as a one super smart AI that can look at any image and tell you what objects are in the image, what exactly each object is located, and separate them with pixel perfect accuracy. The beauty of Mask2Former is that it's built on original Mask2Former but introduces key animation that makes it both faster and accurate. It uses something called masked attention, which helps the model focus on relevant parts of the image while ignoring irrelevant background noises. So, the results speaks for themselves. Mask2Former achieves state-of-the-art performance across multiple datasets, including COCO, AD20K, and cityscapes. But enough theory. Let's understand what segmentation actually means and why it matters. Alright, now let's get our hand dirty with some code. I will be walking you through this Jupyter notebook step by step. You can find the link to this notebook in the description below. First, let's install all the required libraries. We are using the Hugging Face Transformers library, which makes our working with Mask2Former incredibly easy. First, install these packages, then import these packages in our environment. I am creating some helper function which will help in better visualization of our result. As the model gives an output in matrix format, we can't visualize it. So we have to create a function to visualize it. Like this function visualize segmentation result with object names and color lines on the image. And this function show binary marks, which means it show us the solid color of the result on the image, and this is help in visualizing semantic segmentation. Means it's used in only semantic segmentation. Let's run this code. Now I'm going to use a sample image in our notebook. This will be the sample image. This is an image of five cars standing in a standing or overlapping each other, and eh, and there is a background which contain houses, trees, and other things, and the cars are in a parking area. This is a perfect image to visualize different kinds of segmentation. Let's get to our first segmentation. Our first segmentation is semantic segmentation. This is like painting by numbers. Every pixel in the image gets labeled with what it represents. All pixels belonging to person class get one color, all belonging to car class get another color, and so on. Its use cases are various, like in autonomous driving car, it used in identifying roads, sidewalk, and buildings. In medical field, it used in identifying different tissues or organ, and many more. The key thing here is that it doesn't distinguish between different instances. All cards are just cards here, regardless of how many are there. Let's walk it through. I'm going to import auto image processor and Mask2Former for universal segmentation classes from transformer library. Let's run this code. Here I am creating a function which will perform semantic segmentation. I am using model from Facebook Mask2Former Swim Large AD Semantic, which is trained on cityscape data. So I will create two instance processors and model. Processor is used in resizing the image to the model's requirement. Let's run this function. And once more, I'm creating this part to load function using a URL or the image part, which helps me in loading image to the model. Then I will provide that image to the processor as an argument, as you can see here, and then provide the processor result to the model, which will uh, which will help us in finding the semantic segmentation. Then using post-process semantic segmentation, I will resize the output result to the value of its original size and then return the predicted marks, image, and model. I have run this function. Let's visualize it. I will run the semantic segmentation and get three values: predicted mask, image, and model. Let's run it. As you can see, I have gotten a semantic segmentation. You can see every car class got a green color, every building class get a red color, every pavement class get a uh, purple color. So there is no difference between which car it is, but all are detected as car here. This is the beauty of semantic segmentation. Every class belongs to one color. So let's see the binary mask of it. As you can see, you cannot differentiate between different instances of class here. There are five cars in the image, but you can see there are any number of cars can be here. So this is also a problem with semantic segmentation, but it helps us in generalizing where is the object in the image. As you can see, this green area is the uh, uh, car area of the image, and this blue area is the building area. This dark blue area is of the pavement area. Let's get to our next segmentation. Our next segmentation is instant segmentation. This is where things get interesting. Not only does it identify what each pixel represents, but it also separates different instances of same object. So if there are five cars in image, each car gets its own unique mask and color. Its use cases varies a lot. Like in retail analytics, it's used in counting product on shelves, in quality control, in manufacturing. It helps in identifying individual defects on product. In sports analytics, it used in tracking individual player. In medical field, it used in finding cell counting in biology research. This is perfect when you need to know how many of something, not just what it is. Let's run its code. So I have created a function to run instant segmentation. It uses Facebook Mask2Former swim large Coco instance, which use in finding instant segmentation. Similarly, a semantic segmentation, I have created two instances of model and processor uh, and created a function which help in finding loading the image to our function. And I have used the image as an argument to the processor, which provide us with input, and that input goes to model, which provides us with output, and that output is resized using post-process instant segmentation, which return us result, image, and model. Let's run this function. Now to visualize it, we will run this functions. As you can see, our original image has five cars, buildings, and many other things. But in instant segmentation, it only focuses on main parts of image, which is car. You can see there are five cars which different color. You can count it one, two, three, four, five. It helps us in understanding how many cars are there in image and where they belong. So uh, you can visualize this result on the image also. You can see each car gets different color, which is shown here. So this is all for instance segmentation. Let's get to our final segmentation. Finally, our last segmentation is panoptic segmentation. Think of this as the mix of both segmentation. It combines semantic and instance segmentation. It handles background classes like sky, road, grass with semantic segmentation, and things classes like people, cars, animal with instant segmentation. It's used in various scenarios like in advanced autonomous driving systems. It helps in differentiating different cars from background. In augmented reality application, it helps in projecting objects in real world. In robotics, it helps in differentiating multiple instances of same objects from background. And in uh, video editing, it's used in various features of image editing. This gives us the most complete understanding of scene possible. Let's run its code. As you can see, it has same steps we have to follow as previous model. We have to find a model called Facebook Mask2Former swim based Coco Panoptic, which is the model for running panoptic segmentation and provided to checkpoint. And this checkpoint is provided to processor and model. Then same process repeated again, which provides us with result, image, and model. Let's run this code. So to visualize this, we have to run this function. As you can see, the result we have gotten is different from other result. Like it also showed different instance of cars, but also show houses, pavement in a semantic point of view. Like sky is all merged, houses are all merged, but car are in different instance. This is the beauty of panoptic segmentation. We can visualize this on our image. As you can say, a house is in same color but cars are in different color, and the pavement is also in same color. With this, we have seen all types of semantic segmentation and perform it using our Mask2Former model. With this, our tutorial on Mask2Former is over. You can read more about it on our blog. In this blog of Mask2Former hands-on tutorial guide, we will explain about Mask2Former in more detailed manner. You can check it out on our website blog.